The document vector node is a key tool for transforming text data to a numeric matrix representation. It's also very resource intensive, especially if you have a corpus that generates a large vocabulary. To mitigate this problem, we can instead use the document vector hashing node. This node performs the same task as the regular document vector node, but in a different way. It introduces a hashing function to index the resulting columns. The result is that the node often runs much faster than its standard counterpart, allowing for both increases in processing speed as well as reduced memory usage. The trade-off is that it reduces interpretability of the term document matrix, since individual columns no longer correspond to particular words. On this branch of the workflow, let's try out the document vector hashing node. In its configuration, after choosing the appropriate document column, the first option we see is for dimensions. This is essentially the number of columns we'd like to have in our matrix. The second option, seed, can be populated with an integer, and is there in case we need to reproduce the exact same transformation each time the node is executed. We also have the option to choose from a number of different hashing functions, and whether we want to use binary or frequency-based values. On execution of the node and checking the results, we can see that our columns now read call 0, call 1, and so forth, so it's not as clear what those features represent in the data. Still, in many cases, the performance trade-off will be worth it. Note too that much like the standard node, the document vector hashing node also has a complementary node for application, the document vector hashing applier node, which is very similar in functionality to what we've already seen. To sum up, in this video we've examined how we can transform our text data from its usual form into a term document matrix and improve performance using a hash-based approach.